For assignment 13, number 1, part A, this would be able to show that frequency changes the impedance of the capacitor. So we show this through charge equals capacitance times voltage. Current is a change in charge over time. So therefore current is the capacitance times the change in voltage over time. And then if voltage is equal to the current times the impedance, then the voltage over the capacitor equals the capacitance times the change in voltage over the change in times the impedance of the capacitor. So if V equals V naught sine Wt, then dV dt equals V naught Wt cosine Wt. So then the impedance equals V naught sine Wt over capacitance times V naught Wt cosine Wt, or in terms of sine functions, V naught sine Wt over capacitance times V naught Wt sine Wt plus 2 pi, so it's out of phase. So Zc is inversely dependent on W, or frequency. So the higher the frequency, the lower the impedance of the capacitor, and the lower the frequency, the higher the impedance of the capacitor. This is because when current has a high frequency, it switches rapidly, causing the capacitor to not fully charge one way or the other. The faster it switches, or the higher the frequency, the less it charges. So the lower the impedance when the current has a low frequency, the lower the impedance. When current has a low frequency, the capacitor charges more and impedes the flow of charge more, thus creating a higher impedance. When frequency equals 0, the impedance of the capacitor is infinite. For assignment 13, number 1, part B, since the function generator has a max current output that is very small, it can output very large voltage drops. To prevent a circuit element from drawing large amounts of current, a 1 kilo ohm resistor is added, which creates a large voltage drop and reduces the voltage going to the element. If a minimal voltage goes to the element, then its voltage drop is controlled, and so is the amount of current it pulls with said voltage drop. This restriction of how much current and voltage that each element can pull causes the difference in impedances of the capacitor to be minimal, while still varying with the frequency. This minimal change will cause minimal change in the LED's brightness, which will be undetectable by human eyes, thus not allowing the experiment to work.